this is Professor Sawolo, and today again we're going to be going over another section of the West African Examination Senior Secondary School Certificate Mathematics Examination for Liberian schools. Today our video is going to be a little bit different. We're going to try something new. We experienced some technical difficulties, so we believe that the work must go on. So, on this section, we're going to be going over plane geometry specifically. We're going to be discussing about circles. And we're going to be learning how we can apply the properties of chords, secants, should be a T over here, and tangents to find the measure of a line segment on the circle. So the first thing we want to do is to draw a circle and identify some key components of the circle. So let's draw a circle with center at O. Now, please forgive me if my circle doesn't look that perfect. So here's a circle here with the center at O. We know that the distance from the center of the circle to the circle is called the radius. So we have a radius. If we continued it all the way down here towards the other end passing through the center, then we call this the what? The diameter. Then we have what we call a chord. It's something like this. I can give it a name A, B. AB is a segment, is a chord. It has two endpoints on the circle. And then I can have another thing that runs through the circle. Let me give these 2 points to be C, D. Now this is not a segment, it's a line. It runs through this chord. So now CD, which is a line, and please note how I mark them differently. We call this a secant. It runs through the chord. Well, if I also draw another line which just skins the circle, touches the outside of the circle like this, right here, this is called a what? Let me call this point E. It's a tangent at E. Correct? So these are all components of a circle that are very, very important for us to know. All right, good. Now, with this, we are going to look at some different rules concerning the chord. Now, when we have a chord, we also see that a chord, it forms an arc right here. That is an arc. And if I'm describing that, I will write that as A, B, over an arc over it. It's a minor arc. Now there are several rules we have to know to be able to work with circles. So I'm going to go over some of those basic rules. The first rule has to do with congruent chords and arc. So I'm going to just erase this. I'm going to keep my circle here, but I just want to erase some of these basic things here. If I can just clear the circle, and then I just go over some of my rules that I want to go over first. My first rule I want us to go over has to do with congruent and arcs. Well, this is very simple. So I have a circle. Say I have an arc here. Let me call it C. So I have a chord. Say I call it CD. Let me call this M. N. My circle has center at O. So now, if I tell us that MN, the chord MN, is congruent to what? CD, then the arc formed by MN and CD will be congruent. Then this arc will also be congruent to this. So we say two arcs are congruent if and only if their chords are the corresponding minor arcs. Two chords will be congruent if and only if the corresponding minor arcs are congruent. So look, if CD is congruent, if the measure of CD is congruent to the measure of what? N, then CD must be congruent to what? MN. So that's the first rule we have. Now let's look at another rule which has to deal again with segments on the circle. Let's talk about chords and segments that are formed inside the circle. So now, I'm going to go to my next one. Talk about intersecting chords. So let's do it again. Let's draw a circle. And let's look at two chords. Select this. Let's label it. So let's call this, let's say this piece is A, this is B, then this is C, and then this is D. So then, if this is the case, then the product of the parts of this chord, A times B, part A and this is part B, must be equal to the product of the other one, which is C times D. Remember, the chords intersect in the circle. So then, let's look at another one that has to do with secant and segments. Secant. Let's talk about secants, okay? Let's draw it. So we say have a secant from a common external point. This is a point P, it's a common external point. And say, then let's say we have this to be A, and say we have, let's call this B, let's call this C, and let's call this D. So whenever we have this case, then the following rules will hold. So the distance from this external point to the circle, which is B, times the total distance from this external point to that, which is A plus B, must be likewise equal to the distance from this external point to the circle, which is what? D times the total distance, which is going to be what? C plus D. Okay. Then we have one last one, which has to do with a secant and a tangent. So let's look at that one. We're going to just move this one right over here. That's number 4. It says secant and a tangent. So let's go again and get rid of this. Let's go again and draw our circle. Let's put a point right here. So we see that this is a tangent. It comes from a common endpoint. Let's say this is A, let's call this B, and let's call this C. So for our rule, then A squared must be equal to B times the product of what? B times the sum of C. Let me just say BC. B plus C. C plus B is the same thing. So A squared times what? It should be equal to B times the sum of what? C and what? B. Now I'm going to use these basic rules here to be able to deal with problems involving secant. So now let's go to number 1. In number 1, we've been given a circle here, and we have chords AB and CD. We are told that they are congruent. So let's mark them to be congruent. So when I put the same markings on both, it means that they are congruent. Now, Since they are congruent, then we know that they are corresponding intersecting arc, minor arcs. The corresponding minor arc here is AB. Corresponding minor arc here is arc CD also. Then they must be congruent by rule. So I can write, get that look. AB will be congruent to what? AB will be congruent to arc CD. Now, we've been told here that arc AB is 6x plus 14. So I'll do 6x plus 14. That will be equal to 8x minus 4. Now, to solve this, I can move 4 on the other side, add 4, add 4. And I like to be very thorough with these kind of problems because I understand that we all learn mathematics differently. So I'm going to be 6x plus 18 equal to 8x. And then I will divide both, I'll subtract 6x from both sides, 6x minus 6x. So yeah, I'm going to have 18 will be equal to what? 2x, I divide by 2, divide by 2. And I'll have x equals to 9. So we're done. Now, number 2. In number 2, we have to find the value of x. Now, so what we have here, we see that over here we have a tangent, and here we have a secant. So we know that by rule, the square of that tangent segment over there, so we're going to have what? 15 squared must be equal to 9 times x plus 9. This times the sum of this, which is x plus 9. So then we have 15 squared is going to be 225. We do the distributive property here. We have 9x plus 9 times 9 is 81 minus 81 minus 81. It appears that this side is going to be 4. It's going to be 4. It's going to be 144 divided by 9 divided by 9. And what is this going to be? It appears that this is going to be 16, right? 6 times 9 is 54. Put the 4 and carry the 5. 9 times 1 is 9 plus 5 is 14. So we have here x must be equal to 14. So let's now look at number 3. So number 3, we have chords intersecting inside the circle. So we know by rule the product of the parts of each arc must be equal. That is, for example, 6 times whatever we have from here, which is 4x plus 2, must be equal to 4x times 7. So 4x times 7 is going to be 28x. 6 times 4 is going to be 24x. 6 times 2, that's going to be 12. Subtract 24 from both sides, you're going to have minus 24x. Minus 24x. You're going to have 12 equals to 4x divided by 4 divided by 4. You're going to have x equals to 3. Now, so that's basically it. All you have to do is to remember those rules that we laid out. Number 4. So for number 4, we have two secants here from a common extender endpoint. So by rule, we see that it's going to be the outside component, 5x, times the sum of that entire secant, of the length of that entire secant, which is going to be x plus 5x, should be equal to 6 times the entire length, which is 6. And I want to do this so that you understand it. 6 plus 14. So this is going to be 5x here. X plus 5x is going to be 6x equals to 6. 6 times 14 is going to be what? 20. So I'm going to have 6 times 20 is going to be 120. 5 times 6 is 30. x times x is x squared. Well, what do we do next? Divide both sides by 30. By 30, we got x squared equals to 4. Take the square root. It should be plus or minus 2, but taking negative 2, it doesn't make sense in this case. So our answer will be x equals to what? 2. Basic and very, very simple. So that ends our work here. So find some time, go to our website, select some problems on circles, do some practice. Again, try to subscribe so that as soon as we kind of put up new videos, you can have access to those videos and begin to prepare early. Also, like us on Facebook, follow us on Twitter. Thank you and wish you all the success as you prepare for your examination. Thank you.